In this section, we're going to start moving toward the optimization problems that we recall from back in Calc 1. And we're going to talk about maxima and minima. As I've been doing for the last several sections, first thing I'm going to do is ask you to recall these concepts from a Calc 1 sense. So when it comes to maxima and minima, usually the thing that you were going to be looking for would be critical points. Now, a critical point back in Calc 1 was defined as any point where f prime of x is equal to 0 or f prime of x does not exist. So f prime could not exist at a corner, a cusp, a vertical tangent, those sorts of places. Now, places where it's equal to 0, though, these are typically where we're going to find our local maxima and local minima. So here we have a local maximum. Here we have a local minimum. So typically what we would do is we would take a first derivative and set it equal to 0 and try to find all of our critical points and then use some sort of second derivative test or first derivative test to determine whether they were a local maximum or a local minimum. Now, extending this into 3 dimensions, we'll start with the definition of a critical point. A point, we'll call it x0, y0, is a critical point for a function f if one of two things is true. The partial derivative of f with respect to x evaluated at x0 and y0 is equal to the partial derivative with respect to y evaluated at x0, y0, and both are equal to 0. Now, this does extend very nicely using a theorem from the previous section. Therefore, the directional derivative in any direction would be equal to 0. And that is for any direction vector u. This is due to the fact that we would need the dot product of the gradient vector with our unit vector to be equal to 0, but the gradient vector is simply the vector containing both of these components. Both of those would be equal to 0. The other possibility is that either partial derivative of f with respect to x evaluated at x0, y0, or the partial derivative with respect to y evaluated at that point does not exist. In either of those cases, we are dealing with a critical point. Now, in our next video, we'll go over the process of actually finding these critical points, which will look remarkably similar to what we did in Calc 1. Take a couple of partial derivatives, set them equal to 0, and use algebra to solve the resulting system of equations for x and y.